you ready for this? 3, 3, it all adds up. A little bit of distributing here. You might know from back in the day, you can just hop this over once, hop it over twice. 2 times 5 is 10. X times x is x squared. 2x times 7 is 14. It's all positive, and then keep x along for the ride. Another approach you might be into. Maybe you rewrite it. Maybe use this device. Did I do it wrong? Yeah, I did it a little wrong, but that's okay. Maybe on the side, you say, well, it's 5x plus 7. Yeah, no doubt. But then maybe you're a little organized and you say up here, you want this to be 2x multiplying with each of these. This might be a way for you to keep everything compact and maybe double check that you computed everything that you needed. Still getting 10x squared, and then still getting a positive 14x. So maybe this is another approach you use to show your work to make sure that you did everything you needed to do, and hopefully show that the exponents should change respectively. But some of these shouldn't be too bad at all. I mean, this is just going to kick it up a notch, go to the third power. This is now going to go to 30 and then x squared. And a little bit of work down here, but nothing you can't handle for 5. So distribute it up. Take your time. It's legit, no rush. And I'll even approach it with this box method that I've shown over here. If you used it before, awesome. If you're new to the channel, this is another way to FOIL, which I think maybe is a little bit more organized. Maybe it's a way for you to double check that you did everything that you needed to. So start with the numbers first. -2 times -3 is going to be 6. X times x squared is going to get you x cubed. So first box is done. X times -3x is -3x squared. This is done. Careful now, -1 times -3 is going to be +3. Keep x along for the ride. You have your final answer. Boom. And don't forget that 3x squared is negative. To the owner with the sedan, you left your lights on, okay? Maybe take a moment. You know what? Try 2, try 4, try 6. We'll get these all done. And this gives you a chance to get your hands dirty. Check, 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 check it out. Did you get this for 2, 4, 6? Hopefully you did. See you in the set. Some of you are going to have a difference time figuring some of this out. Stupid. F of x plus g of x. You have all of these little sides on your plate. You need to figure out which ones you want to eat first and maybe combine. So you got peanut butter, you got jelly, you're adding them together. So maybe set them up accordingly. Like if this was a normal addition problem, probably write, oh, well, you probably would want x to the 4th and then x to the 3rd. So maybe as a placeholder, you just write 0x to the 3rd and then write plus 5x squared, maybe plus 0x. And this is like a pretty extra approach. Maybe you do this, maybe you don't. And then from there, maybe just line up like what you really can combine, because it might not be too much. Like really, only things you combine are the x squared or x cubed term and the x term. So just combine straight down from here. I mean, 3x to the 4th is there. You brought on a new cast member, 2x cubed, 5x squareds. Not talking to anybody, but you're keeping it enlisted. 0x plus 1x is going to add on x. -1 plus nothing just subtracts 1. Peach, so that's 7. I don't think it's too bad. I mean, do you really need to see this? It's going to be similar, except subtracting the 2x cubed and the x. So I'm not going to show the work, but it should be pretty easy to see why this would now produce a -2x cubed. Still keeps you that 5x squared, but now -x and still -1. Hopefully that makes sense. I think the biggest ingredient you need to be successful with these problems is lining them up accordingly. So make sure you do that. We'll do 11 and also, well, I don't think doesn't be too bad. Actually, this is going to be stupid. These are going to be so simple. X to the fourth minus 9. And oh my gosh, adding on x to the fourth plus 9. 2x to the fourth. No need to change the exponents. -9 plus 9 is going to just add on 0. So 2x to the fourth is your answer. However, if you deduct all of this, so maybe rewrite this one, still m of x first, and you're now subtracting this p of x, so x to the fourth plus 9. So these are going to cancel. -9 minus 9 is going to get you to -18. So boom, your answer is -18. Peach, simple enough. What else do we got? Let's look. 15 has you combining these two graphs. You could focus in on the equations if you'd like, see how they're adding, and they should get you to here. And this is something you could definitely graph out. You could say that you have a y-intercept at -1. You could also push and say x equals -b/2a, and like do all of that. It's totally cool. You can do that. So you know that you have an axis of symmetry at -1/2. Pretty chill. You could push that further, try and figure out where that y coordinate is. A little bit of algebra. Nothing you can't handle though. What's this going to be? -1/2 times -1/2 is 1/4. You're subtracting a half and then deducting 1. A little bit of, fraction work, but you're so capable. It's crazy. This is going to get you -5/4. And is that right? Yeah, that should be right. Is it? Yeah, that's good. Okay, so -5/4. So you're like ballpark down here. This means there's another point over here, -1, 0, and it's gonna like bounce up accordingly. Something like that. And you could also look closely because if you're just adding on, like these y coordinates will actually play a part because like you have a y coordinate here of -2, y coordinate here of 1, and shot in the dark, what's -2 plus 1? That's -1. So you actually could have used these points of like how this was a y coordinate of 2, add on this y coordinate of -1, 2 minus 1 gets you to this 1. That makes sense. That's something you could have done. It works. Try it. You're not convinced. And some throwback right in log form. These are too much fun. Come on now. Your base is A. Your argument is Y. Boom, done. Throw back with 3. Claim 5 equals log base 3, 243. Need I say more? Yeah, let's evaluate some of these. You should not forget these. 2 to some power equals 128. I think it's 7. Correct me if I'm wrong. 4 times 4, 16. 16. Yeah, I think that's about right. If it's not, let me know in the comments below. 8 to some power equals 1. So this is going to have to be 0. Base matches the base, so it's 6. Base 10, common base. Count up how many zeros there are, and that's your answer. Now I'm actually curious. It's 20, right? Let me pause the video and double check on that. I need a calculator maybe. It's a Sunday night. What do you want me to do? Turns out I was right. What a lovely thing to be on a Sunday. And some throwback graphing. You're capable. You remember this, right? Graph each function, label at least 3 points, be precise. There's a vertical shift down 3 units here. And if you need that refresher on what log base 2 of x looks like this. These are actually super cool to draw out. I miss doing these. So there's a pretty basic, not filled in log base 2 of x. And then just take them all down 3 notches. 1, 2, 3, boom. And I'll fill it in so y'all know that's the one I really mean. Take it down a notch. 1, 2, 3, boom. Down 3 notches. Down 3 notches. Down tree. Down tree. And there's no horizontal shift, so you don't have to worry about anything of that nature. Some points of interest that we had 16, 1. We also have 8, 0. We also have 4, negative 1. We also have 2, negative 2 now. Come on now. We also have 1, negative 3. And we also have 1/2, negative 4. Take a moment, pause the video, try 25. Do you remember those points? Do you remember where they should go? How that should shift? Take a moment, try it out. Hopefully you got this for 25, and I think that's all they wrote. If you got any questions, let me know in the comments or shoot me an email. Do something to advocate for yourself. I'm always a fan of students advocating, and especially if I make a mistake, totally let me know. Thanks for watching. Much appreciated. Take care. Brush your hair.